Okay, hopefully you remember from learning it back in school sometime that when you're adding two fractions together or subtracting them, they need to have a common denominator. So if you got two fractions that you want to add together and they already have the same denominator as each other, then your job is pretty easy. You just keep that same denominator in the answer and just add or subtract the numerators. So like 2/9 plus 7/9 would be 9/9, which would be 1. Just like 2 bananas plus 7 bananas would be 9 bananas. So when you're adding or subtracting fractional expressions that have the same denominator, add or subtract the numerators while keeping that denominator the same. And then once you've done that, sometimes it might be possible to simplify the result, reduce it to lowest term. So if you can, you want to do that. But otherwise, it's just a matter of adding or subtracting the numerators and keeping that same denominator. So what about 7x plus 3 over x squared plus 9 plus 5x minus 2 over x squared plus 9? Do you see that they have the same denominator? That makes me really happy because this is a really easy problem. The answer is going to have that same denominator, x squared plus 9, and the numerator is going to be made up of all of this stuff added together. 7x plus 3 plus 5x minus 2. And after you simplify that by combining like terms, the 7x plus the 5x is 12x, and the plus 3 minus 2 is plus 1. So what we end up with is 12x plus 1 over x squared plus 9. And I don't see anything I can do to simplify that. Nothing factors, so there aren't going to be any common factors we can cancel out. So we're done. That's the answer. How about this one? Notice we're subtracting here. 3x minus 2 over x minus 3 minus x plus 4 over x minus 3. So we keep that same denominator, x minus 3, and we subtract the numerators. 3x minus 2 minus x plus 4. The 3x minus x would be 2x. The minus 2 plus 4 would be 2. Wait a minute. Something's wrong here. This is a common mistake that I see people make all the time, but it is a mistake. Can you see what's wrong here? I should have subtracted the 4. The minus here applies to this whole thing, the whole x plus 4. So I am subtracting the x and I'm subtracting the 4. So what I really should have is 2x from 3x minus x. That part's right. But then this minus 2 minus this 4 would be a minus 6. So it should be 2x minus 6 over x minus 3. So now we're done with the subtraction, but we can still simplify the result. This isn't in lowest terms because I can factor out a 2 on top, 2 times x minus 3 over x minus 3, and then the x minus 3's cancel and leave me with just 2 over 1, or just 2 for my final answer. Okay, now for the hard part. What if you're adding or subtracting fractional expressions that do not have the same denominator? Well, then you gotta get them to have the same denominator before you can combine them. How do you do that? How does that work? Well, factor each denominator, if you can, and then for each fraction, multiply the denominator by whatever additional factors are necessary so that the denominators are all the same as each other. But while you do that, also multiply each numerator by the same factor you multiplied the denominator by. Remember, you're allowed to take any fractional expression and multiply the numerator and denominator both by the same thing, and it's equivalent to what you started with. But you have to multiply by the same thing on top and on the bottom. The result of doing that should be that now your fractions do have the same denominator as each other, and now you can go ahead and add or subtract the numerators, putting the result all over the common denominator, and if your result of doing that isn't in lowest terms, then you'll want to simplify. So here's an example that shows how that works with just numbers to remind you how that works. What if we want to add 2 over 9 plus 4 over 15? They don't have the same denominator, so we got to fix that. So here's how we can figure out what that common denominator should be. And if you already see what it is, just bear with me because I'm going to use a procedure that'll work on those fractional expressions. Factor both denominators. The 9 breaks up into 3 times 3, and the 15 breaks up into 5 times 3. And we want them to be both the same. We want them to have all the same factors as each other. Right now, this guy has a 3 and another 3, but he's missing a 5. He looks over at this other denominator and says, hey, you've got a 5. I want one of those so I can be just like you. Meanwhile, this guy over here says, I want to be just like you, and I only have one 3. I need another one. So that's what's missing here to get it to be just like this. So we multiply by those missing factors. The first fraction gets a 5, and the second fraction gets a 3, and then they do have all the same factors as each other. A 3 times another 3 times a 5, which if you multiply it out is 45. But whatever you multiply by on the bottom, you got to multiply by the same thing on the top. So here we multiplied by 5 over 5. Here we multiplied by 3 over 3, which is really just multiplying by 1, because 5 over 5 is 1, 3 over 3 is 1. So what we've got is 10 over 45 plus 12 over 45. 10 45ths plus 12 45ths equals 22 45ths. And that can't be reduced, so that's the answer in lowest terms. Now let's do one that's not just numbers. 2 over x plus 3 minus 6x plus 1 over 3x plus 9. Factor the denominators if you can, and what I see that I can do is I can pull out a 3 down here. I can factor out the 3 times x plus 3. Now to get these both to be the same, what's missing from the first one that the second one has? That would be a 3. If we multiplied this by 3, then it would be the same as this other denominator. So that's what I'm going to do. I'm going to multiply by 3 on the bottom and also on the top of this first fraction. So now on top we get 3 times 2, or 6, and that's over 3 times x plus 3, minus, and we didn't have to change this one at all. It's 6x plus 1 over 3 times x plus 3. So that's what we're dealing with. And now we can go ahead and combine them. We can subtract the numerators. So on top we have a 6 minus a 6x minus a 1. Don't forget the minus applies to both the 6x and the 1. And so after combining like terms, this 6 minus this 1 would be a 5. So it's negative 6x plus 5 over our common denominator of 3 times x plus 3. Which you may either leave in factored form like that or multiply it back out as 3x plus 9. Okay, how about this one? 1 over x squared minus 9 minus 3 over x squared minus 7x plus 12. We're doing subtraction. With subtraction, we need a common denominator. Are the denominators the same right now? No, they are not. What do we do to get them the same? Well, the first thing to do is factor each denominator so we can see what we're dealing with here. So x squared minus 9 factors into x plus 3 times x minus 3, difference of two squares. And x squared minus 7x plus 12 factors into x minus 3 times x minus 4. Now, what's missing from the first denominator that the second denominator has? When this guy looks over at this guy and sees what he's got, what's missing? X minus 4. And then what's missing from here? X plus 3. And they both already have what's missing is an x plus 3, and they both already have an x minus 3, so we don't need to do anything about that. So in the first fraction, the missing factor that I had to multiply on top and on the bottom was x minus 4. In the second fraction, the missing factor that I had to provide was x plus 3. And now they both do have the same denominator as each other, so I can go ahead and do the subtraction. The bottom is just that same denominator. It's got those three factors all multiplied together. X plus 3 times x minus 3 times x minus 4. And on top, we got 1x minus 1 times 4 minus 3 times x minus 3 times 3. So that's 1x minus 4 minus 3x minus 9. And when you simplify that, just combine like terms, you end up with negative 2x minus 13 over that common denominator, which you could multiply out, but that's kind of a lot of work, so I would just leave it like that. Now, warning, one mistake I sometimes see people make with a problem like this one is once you've got your common denominator here and you combine these, it's all over that same denominator, and the numerator would be this numerator here minus this numerator here. 1 times x minus 4 minus 3 times x plus 3. So far, so good. But then what I see people try to do sometimes is, ooh, there's an x minus 4 on top and on the bottom that I can cancel out, and there's an x plus 3 on top and on the bottom that I can cancel out, and then you're just left with just a 1 minus 3 over x minus 3. Wrong. That doesn't work that way. This is not legal to cancel these x minus 4s or these x plus 3s because they are not factors of the entire numerator. The x minus 4 is not a factor of the entire numerator, just part of it. Same thing with x plus 3. The whole thing isn't just x plus 3 times something else. There's also this over here that isn't involved in the x minus 3, or the x plus 3. So do not do this sort of canceling with things that are not a factor of the entire numerator. Okay, one last topic, simplifying complex rational expressions. So that's like when you got fractions in your fractions. The whole thing is one big fraction, but as part of what you have going on upstairs or downstairs, you got a little fraction there. Like this. The whole thing is a fraction with 9 over x minus 1 as its numerator and 5 plus 2 over x as its denominator. Now, one way you can handle this is treat this as a subtraction here and an addition here. So you get just one fraction on top over one fraction on the bottom, and then treat it as a division problem. You can do it that way, but the way I'm going to show you, I think, is a lot easier. So here's how I would do this. Multiply the numerator and the denominator by the lowest common denominator of all the fractions that appear anywhere in the numerator and the denominator. That is, something that's divisible by all the denominators of all the fractions, because that's going to allow you to cancel all those denominators. And then it's just a matter of simplifying what's left. So let's see what that looks like. I see a denominator of x here and a denominator of x here. So all the fractions have a common denominator of x. If they were different, like if this was an x and this was a y, then I might have to take x times y as what would be the common denominator of all of those. But whatever that common denominator is, in this case it's just x, we multiply by that on top and on the bottom. Now watch what happens when I multiply this out. X times 9 over x minus x times 1 over x times 5 plus x times 2 over x. But these fractions are going to cancel out because where we have x times 9 over x, the x over x cancels, leaving me just 9. X times 2 over x, the x's cancel, leaving me with just 2. And so I end up with 9 minus x over 5x plus 2. Not so complex anymore.